can we recap on the formula first? If you want to rotate about the x-axis, then the formula is pi y squared dx. Okay, there's an extra pi and a square for volume. If you're rotating y-axis, it's pi x squared dy. These two formulas are for one curve. The next part below here, I talk about these two diagrams. They will be for regions that have two curves involved. I'm going to rotate this on the x-axis. The question will tell you where to rotate. When you rotate on the x-axis, if your region is bounded by two curves, you will need to judge who is the outer and who is the inner curve. And this is with respect to your rotation axis. You would like to check which curve is further and which curve is nearer to the rotation axis. Personally, I will not visualize the diagram. I wouldn't think about what is the 3D shape. We just go for outer and inner. So what do I mean by that? If this is your rotation axis, y1, which is this curve, is the outer because it is further from the rotation axis. Okay, let's call that as the outer curve. y2 that is below here is called the inner curve. And when should we identify the outer and inner curve? Because you see over here, this whole segment, I call this a gap. There is a gap between the region and your axis. If there is a gap appearing, then there must be an outer and inner curve concept because your region is in between two graphs and there is a gap. Okay, so with a gap, always outer, inner. Let me write down now the volume. So I say outer minus inner, meaning remember to put pi, sometimes we forget. It's y1 squared minus y2 squared dx. Square individually first, then you subtract. On the right, I would like to do that rotation about the y-axis. Let's rotate here. So if I rotate across the y-axis, this time x1 here on the right side is the outer. For volume, it's not about upper, lower, or right, left. It's all about outer and inner. So this is the outer curve.